Okay, in this example, two cars are traveling along intersecting roads. One car is 180 meters north of the intersection, moving towards the intersection at 18 meters per second, while the other is 104 meters west, moving away at 13. Okay. We got this big intersection thing. Let me draw it. Intersecting roads. We're assuming they're intersecting at right angles. We'll just assume that. One car's 180 meters north. One car's way up here. And it's distance away here. It is north, right? North, south, east, west intersection, and moving towards the intersection at 18 meters per second. So it's going this way at 18 meters per second towards the intersection. Okay. The other is 140 meters west. So it's like, yeah, here. And this is 140 meters west. Meters. And it's and moving away from the so it's actually going this way, away from the intersection at 18 meters per second. Okay, interesting. Wait, no, 13. Wait, I lost myself. The other one's 18. 13. Right here. It's moving away from the intersection, 13 meters per second. So, okay. So one of the cars is here, going down that way. The other car is here, going that way. Okay. So that's our deal. All right, let's go through it. What's step number one? Find your rate letters. So you got to identify all the rate letters. Okay. Well, we're going to need to make up some variables. So basically, this car here is going to go do for a while. And let's just stop it right there. And this car is going to go do for a while, and let's just stop it right there. Okay, and then they're going to talk about how far away those cars are from each other. So this is going to be the line connecting them. I'll call this Z. This is the distance between the two cars. And this I'm going to call X, which is from there to there. That's how far that car is from the intersection. And this I'm going to call Y, which goes all the way from there to there. How far that car is from the intersection. So you see what I'm doing? I'm making up some variables that fit this, because then it tells me that dx dt is negative 18 meters per second, because this distance here, which is from the car to the intersection, that's shrinking by 18 meters per second, because this car is going towards the intersection 18 meters every second. So x, this distance of how far it is from the intersection, this is shrinking smaller at 18 meters every second. That's why it's negative. It's decreasing. Whereas y, on the other hand, y dy dt is growing by 13. Growing, increasing, right? Because what is y? Y is how far from this car to the intersection. Started out 140 meters, but it's going away. So y is increasing by 13 meters every second, positive. And finally, what they want is the cars are getting further apart at what rate? The rate of the car. So that's dz dt. They want in the end dz dt, meaning how far apart the cars are from each other. Right, here's this car. So this car's going down, this car's going out. And the distance between the cars is changing by how fast. All right, so there we go. There's our rate letter. Step two, you need an equation that it relating only those letters. No other letters. You can have numbers, but only those letters. In this case, that's X, Y, and Z. So some kind of equation relating only X, Y, and Z. Well, that's pretty obvious, right? X, Y, Z, right triangle, Pythagorean. Here we come. X squared plus Y squared is Z squared, right? All right, step three. d dt, both sides. You know the deal. So I'm going to come in here and go d dt, and derivative with respect to time. Okay, then what do we get? Bring this down. Here comes in 2x dx dt plus, bring down the 2y dy dt equals, bring down the 2z dz dt. Okay. And step 4, plug in the numbers. Plug in the numbers. So first thing we can do, just make life easy, just get rid of these 2's, right? Just divide through by 2. Bye, 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 bye. All right, so now we just need x, y, and z. Excuse me, and dx, dx dt and dy dt. So we come back to the diagram. Here's how we can find x. X is, again, the distance from the car up here to the intersection. Well, it started off 180 away, but it's closing the gap 18 meters every second. It went for 3 seconds. So we can say, okay, 18 meters per second times 3 seconds is 30 to 54 meters. So it closed that gap by 54 meters. So that means x equals, excuse me, 180 minus 54, which means x is, where that is, 126. So x right here is 126. That's how far away from the intersection that car is, right? Because it started out at 180 and it's getting closer by 18 meters every second. Does that for 3 seconds. They told 3 seconds later it went 54 meters. That means 126 away. What about y? Y is going 13 meters per second times 3 seconds, which is 39 meters. So then y is going to equal the 140 plus the 39. So y is going to be 179 meters. Y right here must be 179 meters away. Does that make sense? Because y started out 140 meters away, and it's going away, adding to that 13 meters every second. So it does that for 3 seconds. It's 39 meters added to the 140. Now it's 179 meters away. And then I can get z also from the Pythag, right? You know how that works. X squared is y squared is z squared. So x is 126 squared. It's y squared, which is 179 squared, equals z squared. And then root it. And root it. And boom. So z equals that right there. Oh, we can probably simplify that. 126 squared plus 179 squared. Let's go to decimals. 126, 179, 126, 179. 6, 6. Is that right? 126. I think I got it wrong. 126, 179. 126, 170. Yeah. Is 47, 917. 47, 917. 47, 917. So it's going to be the square root of 17. So there's z. All right, we got x, y, and z. Let's bring them down. So we got x. What was x? 26. And y is 126, and y is 1. Well, let's do 1 at a time. X is 126 times, what's dx dt? Dx dt negative 18, because it's closing, it's shrinking, it's negative. Plus, what is y? Y is 179. And dy dt is right there, plus positive 13, because that's growing. Right? Rates that are growing are positive, shrinking are negative, equals z. Is that weird square root thing. Square root of whatever it was. 47,917. No, I didn't put that. 917. And then dz dt. All right, we're going to solve for dz dt. We are right on the cusp. Divide both sides by that square root. So here we go. 47,917. 47,917. Boom, boom. All right, let's go to Desmos. 126 times negative 18. So 126 times negative 18. So fraction times negative 18. No, I lost the negative. I need that negative. Plus, oh, and I lost the 18. Come on, baby. Plus 126 times negative 18. 126 times negative 18. 179 times 13. 179 times 13. 179 times 13 over the square root of the answer we got in the previous one. Right? Square root of that. Enter. There it is, 0.2695. 0.2695. 2695. And notice it's positive. So that means it's growing. It's growing. It's increasing. The distance between the cars is increasing, 0.2695. Yeah, they just rounded to 0.27. But yeah, and further apart, right? If that had been a negative answer, they would have been getting closer instead of further apart. But it's positive, which means the gap between them is growing 3 seconds later. And so there we go.